Hello, hello, and welcome everyone to the Bringing IoT into the Cloud Continuum panel. My name is Marco Gonzalez, and I am the head of AI and data here in Ikerlan. And this session will focus on the integration of the IoT devices into the edge to cloud continuum. In this case, we are dealing with constrained devices such as sensor, actuators, IoT devices that increasingly needs to load compute intensive tasks to meet latency, scalability, and reliability requirements. Coordinating intelligence across these constrained devices, edge nodes, and also the cloud is one of the hardest problems we see in the industry and also in research projects. And we are focusing in that in the COGNIT project. Today, we will explore how this coordination actually works in practice, what is difficult, what breaks, what needs to change, and when can we implement. We will try also to make this panel as conversational as possible, but we have with us four experts that I will give place right now to introduce for themselves. First of all, Ignacio, please.
Yes, good morning, Marco. Good morning, everybody, and of course the audience that are hearing us. My name is Ignacio Lacalle. I work at the Universitat Politécnica de Valencia, which is a polytechnic university at the southeast of Spain. I have been working for the last 7 to 10 years in the world of Internet of Things from the side of the research and the public university, meaning I have participated in research projects in several ones with different positions such as coordination, technical development, but also impact creation. Therefore, I believe I can bring a vision about how the difficulties in the technical side can be solved and how these type of projects help to progress in the integration of the cloud edge IoT computing continuum and IoT devices. It's a pleasure to be here and looking forward for the panel.
Thank you, Ignacio. Next, we have from the research center part, we have Xavier.
Hello, everyone. My name is Xavier Lesage. I am a researcher in AI and cybersecurity at CETIC, a research center in Belgium. I work essentially on distributed systems, cloud, edge data processing, and secure phonetic learning.
Thank you, Xavier. And next, we have from two industry experts, Kaya and Xavier. Please, Kaya.
Hello, my name is Kaya Svat. I work at Phoenix Systems. We are actually a developer of Phoenix RTS, which is an operating system dedicated for IoT devices. I've been at Phoenix for 10 years now, so I have quite a bit of experience into the development of the system, but also in deploying even mass production products that are based on our system, the IoT devices. So I've seen a lot of problems that we overcame finally. We are also a partner at the COGNIT project, so the research side is also something that we are interested in and we are pursuing. So I'm happy to be in this panel and share the experience and share thoughts with you guys.
Thank you, Kaya. And last but not least, Antonio.
Yeah, hello, good morning, thank you. Good morning to everyone. I'm Antonio Laguna, CTO in Acisa. Acisa is an integrator company. We provide solutions of integration, end-to-end solutions in critical sectors such as energy, traffic management, or smart city. And I have background more than 10 years in the IoT in different companies and startups. And my background is mainly in the integration of different IoT devices, integrated with cloud computing, artificial intelligence, and so on. How to give a vision about the industry and how to incorporate those new developments and innovations in the cities.
Thank you, Antonio. So let's start with the panel. The first part, I wanted you to focus in what is the current state. Right now, we have a lot of devices. We keep adding more and more IoT devices in the field. Also, edge nodes. Also, with all this computing on cloud nodes. But we have a lot of different architectures patched together. We want to have any standard. Yeah, so before talking about how to solve this, about the solutions, let's talk about what is not working or what we need to solve. So maybe we're going to start from the research or university, and then we complete the image from the industry. So maybe Ignacio, you can start saying what do you think is not working in this IoT edge cloud continuum nowadays?
Well, I think the question, and thanks Marco for making it, it's quite multi-angle and complex. The answer for such a question, especially because you have portrayed the question such as what is not working in the cloud edge IoT continuum. And this is a multi-tier structure, and each of those entails their own challenges. Therefore, one thing it's the integration among those layers is challenging per se. But if I would need to focus on what I am more expert, which is in IoT in the edge part, I would say that one of the issues that makes it not work is not really understanding the heterogeneity that these devices have in several ways and forms. For instance, we usually see that IoT devices are so siloed in terms of their conception and their deployment to specific sectors, and they do not resemble in terms of protocols, data exposed, how you interact with them to others sectors. So they are basically very fragmented and siloed, which prevents, in my opinion, prevents for a real smooth integration towards upper layers such as edge and cloud. And at the end of the day, although massive deployments and large scale ones are already taking place, it's still very customized, tailored, very dependent on which is the underlying hardware you are purchasing for these devices. It's a complicated process to clearly scale and to apply the same recipes in different sectors. So, meanwhile, in certain areas such as in cloud and edge, it's possible that some technologies become de facto standards and can be used as a massive scale. When you go to the IoT devices, the difference is so big, the heterogeneity is still so present that I think that's a challenge. So to my eyes, that's one thing that it's right now making it not work for the general public, let's say, or for the global applications from the research side. So I would like to start saying that.
Before passing the question to the next one, maybe there is also some problem about the naming, because depending on the sector and on the client that is using this IoT edge cloud, IoT edge and cloud names can mean different level of performance of equipment, etc. For example, some people can a Raspberry Pi can say it's an IoT device. Others can say it's a small edge node. Another, so maybe Xavier can say a bit more, but I think naming is sometimes misunderstood, or is a different definition in each one of the verticals and sectors.
Yes, exactly. And what is not working today is the lack of systematic overview to IoT devices and edge nodes are added project by project, often driving by the hardware and short-term needs. So it's very hard to orchestrate and even harder to secure over time. So the issue is not the lack of technology, but a lack of global coordination between edge, cloud, and data.
If I may say something, sorry, Marco, but I would like to say one thing before passing to the other colleagues.
Mm-hmm.
You mentioned naming, and I think that's very important, and it's true, and it differs from project to project. But just to point out that for me, another issue for what's not working is because there is no really single reference company or reference entity that it's the main promoter of these technologies. In the cloud, you have companies such as AWS, Google Cloud, Azure. You know which path to follow. In the IoT and edge, it's not that clear, and I think this compromises the challenges that there are today.
And
There
how
are
do you
many examples of the companies that, with what they have done, they created like a de facto standard, and in IoT world, this wasn't done yet. I think, Ignacio, this is what you are saying, and I fully agree.
Exactly.
If I may continue, Marco.
Yeah.
From what I see two perspectives that are a bit different. One perspective is the end user. It's a normal guy or a girl that is using IoT devices like home appliances, buying them. And these are us. We are like amazed by the technology and the possibilities that the technology can give to any one of us. And we are marketed with the possible added value that it can bring to our life. It can change our life. So we are chasing those new functionalities with buying new IoT devices. And because the lack of heterogeneity that Nacho was saying about, we end up drowned in applications for managing those devices. We actually don't know what is inside those devices, what this technology is actually doing besides the functionality that we see, which is possible security issue. And well, obviously we are not doing anything about it because we are end user. So this is the perspective of the end user. The other perspective that I see is perspective of big public procurements from energy sector, which we are very active in. So this works a bit different, and it actually changed over the years. That what is wrong about those procurements, obviously they are really slow. And we are often drowning in a paperwork, but the end user that is a public sector nowadays is mindful about the technology, what it actually does, where it comes from, what are possible security issues, interoperability. So these mass deployments and the mass public procurements, they do have a bit different perspective, and they are more mindful, and they are looking forward the homogeneous IoT world.
Okay. And Antonio, how do you see this as integration, especially in critical sectors? Do you think this is a problem, or how do you see this challenge?
Yeah, well, yes, indeed, is one of the problem, no, and one of the objectives, indeed, of what we did at AFISA is precisely to make those heterogeneity more transparent to our customers. So we try to make those integration of. You might imagine that in a city, to manage the traffic, you can have hundreds of thousands of different devices connected to a control center just to manage the traffic in a city. All those traffic lights, panels, information messages, detectors are from different companies, from different providers with different protocols using different, even different electrical specifications. So it's quite challenging to integrate all of them. But from the perspective of our customer, they don't want they don't care about this heterogeneity. They want a solution to manage the traffic. So we need indeed to provide this layer of of transparency. And regarding the lack of standards and so on, from a perspective, there is not a lack of standards, but indeed a lot of them in the IoT sector. The problem is that there are many of them, and depending on the domain, there are different standards to be implemented. And in the end, it's quite challenging to make an easy solution from all of them. No, we are working indeed to try to standardize, to make like a semantic layer from the different systems in traffic in order to standardize how the systems are facing to the cloud. No, how to manage from the cloud perspective, how to deal with all those devices that might be in a city or in a traffic in the traffic sector. No, but in order to do that, we need to work with different stakeholders, no, in order to arrive to a common standard for that. Not only that, and indeed, sorry, another challenge is not only those heterogeneity, but indeed for a sectors like us, it could be similar in energy, but the other challenge is that those systems installed in the street cannot fail, even if the communication, even if the cloud solution is failing, the systems in the street must continue working, right?
All of you said standardization and interoperability is important. Also, Xavier talk about coordination. So when we are talking about making place for this IoT in the edge cloud continuum, because edge cloud uses, we can say, similar technologies, but the IoT have more higher constraints in terms of communication, latencies, performance capabilities, etc. Here we have one of the real challenges is how to coordinate this heterogeneity of systems. We have to take in account, as you said, also security and reliability, but also latency, performance capabilities, autonomy, etc. So when we are trying to implement this coordination in the not edge cloud, but IoT edge cloud, when we have the IoT that is a totally different animal, what do you think is the best way to make this coordination of this? Normally, we in the edge cloud continuum we talk about also about offloading of tasks. So, how do you see which should be the perfect architecture? Should be centralized, distributed? How is for you? Maybe Ignacio can start, and then we will go by all of you.
Okay. Yes. Thanks, Marco, for the question. Again, I think you have touched different parts in your question. It was quite a long one. When we are talking about how to better manage it and how to better take advantage of the task of loading, that is a thing that you mentioned, to my eyes, the best architectural approach is what we consider a federated approach. Federated in the sense of moving from a centralized approach, but not really having only decentralization as the main thing. Meaning, federation in terms of allowing for decisions to be taken decentralizedly, but having a vision of the whole continuum, the whole topology. This is a concept that we have been exploiting in a project that we coordinated very recently that was called AEROS, funded by the European Commission, that just finalized very recently, in which we took advantage of the concept of publication and subscription and federation of context brokers with context zone registrations in a way that you could offload tasks, dropping the services you wanted to be deployed in any part of a continuum, close to an IoT device, close to an edge computing, close to the cloud. The decision is taken there locally, but considering and having in mind the current status of the network of all the computing elements. Mm-hmm. This has proven to be very useful, very scalable, and very flexible to introduce new computing capabilities, new IoT devices, etc. This is for what concerns the part of architectural goal that you mentioned, mm-hmm. For this part of task offloading. However, I would like to touch upon a bit more on what you said about that IoT is a different beast. And IoT, when you go closer to what the device is, it's a very different beast. And I absolutely agree with that. And I would like to highlight only two things before passing the floor to my colleagues. Is that some aspects that sometimes are overlooked until you are basically on the field doing actual deployments of sensors and actuators, which is autonomy, energy capacity of the batteries that the IoT sensors have, if they have access to the energy grid, which is not always often available, which type of network coverage you can bring to them, if this network coverage is stable, and also IoT devices and actuators, they crash, they stop working, they don't say often reliable data, they send false positive values. Although they are well calibrated, you always face these type of situations. So I think that we tend to generalize too much, overlooking the difficulties that the field deployment have with IoT devices. And this is a thing that I don't know how it will be solved in the future. Maybe using more lightweight technologies, more standardized hardware and processes, but I believe it's still there.
Maybe Kaya, you have also experience in implementing in the field. Maybe you can, especially in the second part that Ignacio answered, maybe you have also some experience about the problems that they get also in the real life.
So we are actually focused on resolving the problems that Ignacio was talking about, as we are doing the operating system for IoT devices. So our main concern is for the devices not to crash, for them to have connectivity which is not dependent on us many times, but on the network that is provided to the IoT device. So we are also focused on how to maintain operability of the device, even though it's not currently connected to the network, which is a headache, obviously. But there are many problems in the IoT device layer, and I think going back to the main questions, that each layer of the continuum has different kind of problems. So in order to have the continuum working well, it is what is the most important is that we have the technology on every part of the continuum, that we work. Like there are people like us working on IoT devices, we focus on that. There are people working on the orchestrator, people working on the solutions for edge technology. Because at every layer, there are multiple problems that need to be addressed. So what is the most important for me is that we have the technology here in Europe, the experts here in Europe, and we have the knowledge. We are gaining the knowledge through the development and deployments, and we are actually using it. And in terms of the architecture, what the architecture should be, it should be decentralized and centralized. Is once we have the technology, we own the technology, and we know what we are doing, we can have decisions divided between those layers. So the IoT device is capable for making some part of the decisions in the whole decision chain of the Continuum orchestrator, obviously also. So the architecture should be meshed.
Mm-hmm.
Maybe it's similar to what Ignacio was saying about the federalization. There should be something that has an overview on the whole network, but also parts of the architecture should be decentralized, because sometimes there will be no connectivity, and obviously we want the functionality without the connectivity as well. So meshing the functionality, I think, is the best way, especially if we also look at the use cases that are requiring mobility. and the IoT devices and edge devices are moving across not the virtual continuum, but across very real space and time.
Yes.
You were talking, both Ignacio and Kaya, about distributing, federating, mesh, etc. For example, Antonio, how this matches all this federation, distribution, etc., matches with a critical, like for example, ATS or a critical sector? You think that this federation distribution increases reliability or makes it harder, or how you think that this technology matches with critical sectors?
Yes, I would say both. It of course is a need because it's the way to make the system more resilient. But of course, it that complexity. So you need solutions to have that complexity and to make it affordable. In our case, the IT sector has been working in let's say distributed system almost from the beginning, no. Even when we didn't call them distributed, but by the how the architecture, how the systems are in place, they need this distribution. For example, the traffic light controllers need to work even if there is no server, central server, or even if there is no cloud. So when you start to connect those systems, when you start to centralize, very soon at the beginning, when everything was centralized in a single server, you realize that if it was the only point of failure, no? If that server fails, everything fails. So you need to add some autonomy to all those IoT systems, no? Even also, but when you go to the cloud, if you are only relying, for example, in AWS, it can happen that it might also fail, no? So you need also redundant system, either different clouds or even your out cloud redundantly. No, we did have faced this example, no, of the last lockout in Spain that happened this year. What we saw in the system that in the different cities that we have giving services is that, for example, those cities with traffic light controllers with battery keep working, no? even without electricity or even without connectivity. No? Our system, our cloud that is based on our own CPD redundancy with the redundant power, keep working even in the lockdown. No? So this is the way in critical system to go. No? Of course, at the end, the federated system that Ignacio meant is like the objective to go. No, but this is like an incipient field yet. So yeah, I think that the solutions will go to in that direction, of course. Yeah.
And Xavier, how do you think that the architecture, for example, that you are using in COGNIT can help in this matter? And another one, I like to make long questions, sorry.
Yes.
But we are all talking about distributing, federating, etc. But normally we focus in distributing, federating, meshing applications or intelligence. But I think a non-easy question is how you can federate or distribute data also. I know we have DLT, APFS, etc. But I think it's two questions.
Yes, exactly. So for the COGNIT project, we have the opportunity to use an AI for the anomaly detection based on LLM architecture. It was a little LLM. And so with the autonomous car, we have the sensitive data in the car. And so to train an AI, sometimes it's very difficult to train an AI with the sensitive data. And so it's needed to make the training without transfer of sensitive data. There are a lot of autonomous cars, and if I would like improve an AI for the anomaly detection, of course, it's needed to have a lot of data. And so, thanks to the federated learning architecture, it's possible to use this local data without transfer of sensitive data. It's a paradigm. It's very very nice to train an AI without transfer of data, but it's very important to secure the communication between each client device. So generally, it's needed to add some extra security like differential privacy or SMPC. So yes, with the phonetic learning architecture, it's possible to train an AI without sensitive data. For the medical sector, for the energy, for the mobility, generally we have the same problem. It's very difficult to share the data, and generally the data is locally in the device client.
Okay, as you said before, all of you, we are talking about distributing and federating. For that, we need an orchestrator or someone to tell,
Yes.
hey, where should we go? Should it go each one of the applications intelligence data? But that orchestration have to focus in some metrics or non-functional requirements, or as we like to know, was, for example,
Yes,
energy, bandwidth, etc. What do you think is the most important or the best way to orchestrate?
Yes, it's very important to have an AI orchestrator or similar because it's important to have a solution based on a global view. It's important to have a global view of the architecture with local feedback. And thanks to the AI, of course, it's possible to have more information with the XAI explainability. So it's possible to have the good metric to take a decision and change a component on the architecture. So it's very important to have a master orchestrator with an overview of all architecture and depending of the problem, latency, resources, performance, etc., to change or move several tasks from the node 1 to the node 2, for example. Voilà. Especially for the critical sector.
Yes, but if I may say something here, Marco and Xavier, I agree, but we shouldn't, we shouldn't let people be confused about the term master orchestrator with a centralized one.
Yes.
There is no need for that.
Yes.
You can have a global vision of the whole network and topology of computation to take your AI-based decision, trying to optimize the allocation based on whatever parameters you want to optimize, but not necessarily this needs to be centralized. You can give more power or take these decisions locally.
Yes.
With the global vision of the whole network. I agree with that, and I think that's a very good observation. Also, in this sense, it's critical to understand that it's very important how you select your KPIs that you want to optimize. If you want to do your offloading because of, or you want to optimize latency or reliability or energy consumption, it's now being also more and more considered in this regard, or cost or network reliability, whatever. So yeah, I agree with that, and I think it's a very good field of research that is now quite active, and there are some concepts are emerging, such as the cascade decision drift, which is one concept that we are exploring as well, which means you take a decision of allocating a workload across your edge computing or IoT edge cloud computing continuum infrastructure to optimize certain parameters, such as the global capacity of your computing network, or the shortest path, or the latency. But by the fact, or because of the fact of having selected that specific node to run your workload, you have indeed affected the network, that if you had done this before, you wouldn't have selected this node. So there is some trade-offs and compromises that do need to be reached. And I think this is a very open and interesting field of research right now.
I was going to ask exactly that, Ignacio, so you predict that. But also I want to add that is also important to know what KPIs we should measure, but how to measure them, how to communicate the metrics, and how to accurately evaluate all these KPIs. But I want to go to the last block. Question to Antonio and to Kaya is, okay, this is the technical challenges and how we can solve them, but I think that all these system architecture, especially in Europe, in the European Union, are very shaped normally by sovereignty, regulation, especially with the Data Act, the CRA, the AE Act, etc., interoperability, etc. So how do you think that Europe can shape these IoT edge cloud architectures with the regulation or with the standards, etc.? You think that Europe has to put work on this? We are very good at the regulation, so.
We are very good at regulations, but actually we have made changes over the last years in Europe, starting from the public sectors I was previously talking about, especially the energy sector. Well, they became very mindful about where the technology is coming from, where the devices are produced, where the software have been developed. So sovereignty plays a part now, and this is because we started to understand, we as a society, not the guys behind the IT, but we as a whole society, as Europe, we started to realize that there are threats behind the technology. If you are not knowing what it does, and obviously if you don't know where it came from and what it actually is, you don't know what it can do. And especially if you are responsible for a sector that is vulnerable to threats. And energy obviously is a sector that has to be working always. We've seen last year in Spain what happens when there are problems. So this sector is very mindful about the technology itself, and they are looking for solutions that are made in Europe from scratch, and for people that understand what is behind the technology. So I think this changed over the last few years. And in terms of the whole European ecosystem represented by European Commission, also a lot of steps were made to drive this change. We have the IPSE Cloud project that is a very good initiative of the Commission to drive the developments in IoT Cloud Edge Continuum. We are standardizing with the Data Act, with AI Act. So we are doing a lot. What we could do better, we could do it a bit faster. But I don't know if it's possible with in the EU. I'm already very happy that we are taking those steps in the Europe, and we should go definitely in this direction.
Antonio, you think that
Yep.
for example, CRA for critical sectors can be very important?
Well, yes, I agree with Kaya that in Europe there has been a lot of steps. They are making a lot of efforts in order to try to standardize, normalize, and make innovation in Europe now. But there is also a view from well, depending on what you are in the in the whole chain, that eventually you can see Europe as an organism that punish you. That is there to punish if you are not compliant with some regulation. No, for example, in the case of cybersecurity, they are getting really tough even more in Spain than Europe, but Europe is following Spain in the sense, no? Because we have the Esquema Nacional de Seguridad, the ENS, that is a very tough regulation in terms of cybersecurity. But now the NIS 2 is a regulation for Europe that almost mimics this Spanish regulation. So, but I think that the approach from the Europe would be more to help European companies to growth and to make innovation rather than to punish them.
I have one more thing to add on top of that. I was recently thinking about how what else Europe could do as a whole, and that is to actually use the technology that we are developing. For example, in COGNIT or in IPSEI. There is a lot of technology that could be adopted by public offices. So my postulate would be for those public offices to stop using hyperscalers and start using the technology that we are developing in Europe.
Yes. I think, if I may say something here, I agree 100% with Kaya here. And also bringing more visibility to what we are doing as a result of research projects that can be used and is useful, and are even alternatives to some things being used in public offices and in companies that are not European based. You ask Marco of what Europe can do in terms of regulation, standardization, etc., for trying to be more competitive and to try to permeate or influence this sector. This is my personal opinion, but I don't believe we should bid for more regulation or standardization, because this takes a lot of time, and unless it is accompanied by the mandate from the governments to use that standard, it's not clear how important or how impactful it is. Just last perspective. Since I also come from a research background and a university one, in the edge and IoT and cloud perspective, we are in really different projects making a lot of open source public that can be used. So I would like to say, instead of regulation and standardization, promote more the open source results of the projects and use them more. It's possible and it would be good.
I was saying that also it's not only legislation, laws, etc. Could be investment also. Investment in open source European technologies, for example. Money is important to make these technologies be more mature and be adopted by industries, by public sector, etc. So, okay, we have 8 minutes left, so I would like to ask you for one sentence to close the panel. Maybe start by Xavier, and I don't know, about what do you think should be the next steps for establishing this IoT edge cloud continuum? Could be the technology part, the investment, the legislation, the solving problems, etc. So, what is for you?
For me, the next step probably with the regulation to have a good overview of the architecture, the traceability of the activity in the edge computing. So to be according with the regulation, for me, that will be the next step to have a certification NIS 2 to be certain all is okay with the explicability with the AI Act, Data Act.
Okay, thank you, Xavier. Kaya?
For me, we will continue to focus on the development of software solution for IoT sector. that are sovereign, that are safe, and that include security features, and we will continue to gain knowledge about the technology by developing it. What I need from the public offices is to be able, for example, to test them. Because I know that my fair chance will be if we are actually tested against another technologies, not with filling in the boxes during public procurement, but actual security tests. That is one thing, and the other is what we said before, for the technology to be used. So the government, the member states should drive to use the technology that is being developed currently in Europe.
Okay, thank you, Gaia. Antonio? Wait, you are muted.
Yeah, as an integrator that we are in the middle, no, in between the end customer and the cloud providers. Our objectives would be keep to maintain to build reliable systems that with systematic and easy deployment for us and for our developers that ensure reliability, but also compliance and access to innovations to our customer, no? to easy access to latest innovation in terms of, I don't know, artificial intelligence, blockchain, whatever, no? So just to make this a transparent layer to our customer to allow them to access to the latest technology and innovations.
Thank you, Antonio. And to close, Ignacio?
Yes, just some final words from my side. I believe that it's important now to make a bit more visible, communicate and disseminate better success stories in large environments where EU-based technology for IoT, edge is possible, is desirable, and can really have the same benefits than using large US or China deployments. And by doing so, leveraging this open source coming from the work that the researchers in you are doing, we might be able to better smoothen the challenges of integration of the IoT cloud continuum that are still today, especially in sectors that are now of the essence of challenges that are societal and economical, such as mentioned by Kaya, energy, but also agriculture, manufacturing, and other relevant sectors. So, and this is what we are betting for the short-term future. Large-scale piloting of these EU-based open source technologies to demonstrate it's possible to create success stories. That's all from my side.
Thank you, Ignacio. So, with time's up almost, so thank you to all our panelists, to Antonio, Xavier, Gaia, and Ignacio, for also all the open discussion, the insights, and thanks to everyone which is watching us today. So I hope this session help you clarify what we are today, what are the challenges and the opportunities for the IoT Edge Cloud Continuum, and thank you.
Okay, thank you for organizing.
Thank you.
Bye-bye.
Marco.